Welcome to another episode of ResearchPod. Today, we're looking at how we might bridge the gap between the massive intelligence of cloud-based AI and the practical needs of our own devices.
The puzzle is how to build AI that is smart enough to solve complex tasks while staying cheap and efficient enough to run on a phone. That's the question at the heart of this research into what the paper calls hybrid multi-agent systems.
So the paper is basically asking, how do we get the best of both worlds, the power of the cloud and the efficiency of a device, without just picking one?
Exactly. Cloud-only AI is expensive and raises privacy concerns because everything you do gets sent to a remote server. But device-only AI often struggles with complex reasoning because phones and laptops just don't have the processing muscle of a data center. This research explores a middle ground. A small local agent handles the day-to-day work, and a powerful cloud model steps in only to supervise or correct course.
So the cloud acts like a supervisor rather than doing everything itself. How does that play out in practice?
Think of a master architect and a contractor. The contractor, our on-device agent, does the heavy lifting on site. The architect checks in periodically, and if the contractor gets stuck or goes off plan, the architect steps in to get things back on track. Most of the time, though, the contractor is working independently.
That makes sense. You're separating high-level thinking from the actual execution. Is that why it's called a multi-agent system?
Yes. Multi-agent just means there are two distinct roles, the supervisor and the executor. By keeping the executor on the device, you avoid the cost and delay of sending every single action up to a server.
Right. But what happens if the local agent gets confused or goes in circles?
That's where the idea of a verification interval comes in. Rather than checking in constantly, the system checks with the cloud every few steps. And here's the clever part. When the cloud does intervene, it also clears the agent's short-term memory and hands it a tidy summary of what's happened so far. The agent can start fresh without losing the thread of the task.
It's like giving the agent a fresh notebook with only the important notes, rather than every scrap of paper from the last hour.
That's exactly it. And the reason this matters is that on-device AI has a hard limit on how much it can hold in working memory at once. If that memory fills up, the system slows down or starts making errors. The reset strategy keeps things running smoothly within those constraints.
Are there different ways to set this up?
The paper describes two main approaches. In the first, called PEVR, the cloud gives the agent a strict step-by-step plan up front and checks whether the agent is following it. If the agent drifts, the supervisor resets the memory and issues a corrected plan. In the second approach, called EVA, the agent works much more independently. The cloud only provides a brief summary and a light nudge when it spots the agent struggling. Less like a project manager with a checklist, more like a mentor who trusts you to figure most of it out yourself.
So one approach is tight control, the other is guided autonomy. Which one works better?
The research found that neither is always better. It depends on the task. That's actually one of the more significant findings. It means there isn't a single correct architecture. The right choice depends on how structured the task is and how much the local agent can be trusted to handle it.
So the practical takeaway is that these systems need to be matched to the job, not just deployed universally.
Right. And looking ahead, the researchers suggest the natural next step is systems that can switch between these approaches dynamically, reading the complexity of the task in real time and choosing the appropriate level of cloud involvement on the fly.
That would be a meaningful improvement. Rather than committing to one management style, the AI decides which kind of oversight it needs at that exact moment.
Precisely. And that flexibility is what would make these systems genuinely practical for everyday use, capable enough to handle complex tasks, but efficient enough not to drain your battery or compromise your privacy.
Before we wrap up, what are the honest limitations here? Why aren't systems like this already everywhere?
The researchers are candid about this. The study covers a specific set of models and scenarios, so we shouldn't assume these results transfer automatically to every situation. Running these simulations is also computationally expensive, which meant the team couldn't conduct as many repeated trials as they would have liked. So, it's a solid proof of concept, but not yet a stress-tested universal solution.
A meaningful step, then, rather than a finished answer.
That's a fair way to put it. The research shows that decoupling high-level reasoning from the moment-to-moment execution is a viable path forward. The details of how to do that well, across more tasks, more devices, more real-world conditions, that's the work still ahead.
It's been a grounded look at how we might actually make advanced AI work within the limits of the devices we carry around every day. Thanks for walking me through it, Sam.
My pleasure. Thanks for listening to ResearchPod.